Ooh, this is a long time coming. So I'm looking at, this is the last page for the pre-calc test study guide, page 4. So we got a couple things to do. We got uno, dos, tres. So let's just jump into it. So convert the following from rectangular coordinates to polar coordinates. We said earlier that this was wrong. Is convert the following from rectangular form to polar form. And just so we're clear again, rectangular form, you know what, I'm just going to abbreviate this time. Rectangular form is a plus b times I, and I want it to go to polar form, which is r times cosine theta plus I sine. I'm going to run out of room. Let me write that again. Let me write this up here and write it correctly. So first let's put form, say right here, and then we say polar form, and that's r times cosine of theta plus I sine of theta. So that's polar form, that's blah blah blah. So what do I know? Well, I know I need r and I need theta. I know r equals the modulus, which is the square root of a squared plus b squared. And then the theta, or my argument, is the inverse of tangent of b over a. Okay, so let's jump right into it. So let's start with getting r. So r for this case is the square root of 4 times the square root of 3, that's my a, squared, plus negative 4 squared. Well, negative 4 squared is easy. Negative 4 times negative 4 is positive 16. Now, when you got a problem like this, I'm gonna write it over here. So when I have 4 times the square root of 3 squared, that means I have 4 times 4 times square root of 3 times square root of 3. You gotta square both pieces, right? Because a 4 and a square root of 3, they don't interact. But when I multiply these two things like that, I get 16 times the square root of 9. Because the square root of 3 and the square root of 3, they're both under the square root, so they interact. So then I multiply those, that's 16 times 3, and 16 times 3 is 48. So I got 48 plus 16, that is the square root of 64, if I add those together. And the square root of 64 is 8. So that's my r. Next, I need the tangent, or the inverse of tangent of b over a. So the inverse of tangent of b, which is negative 4 over 4 times the square root of 3. Now I'm going to steal some more space from down here so you can understand that if I'm looking at negative 4 over the square, the 4 times the square root of 3, the 4's can cancel off. So I could just write negative 1 over the square root of 3. So either one of those will work when I plug it in. So let's plug it in. All right, so what's important, I'm checking, I'm in degrees. So I'm going to say, you can't see it. Okay, there. Come on, you're making me look bad here. Okay, so I'm going to say trigonometry. All right, so now I want you to see a little closer. See, I'm going down to these are the inverses. So I go to the inverse of tangent, right? And now I need to put either negative 4 divided by 4 square root of 3, or I need to put negative 1 divided by the square root of 3. Let's see if we got enough time to do both. So because I'm doing a square root, first off, I want you to see this. All right, so many times, this button right here is the negative. So I need to say negative 4, so I push this button and say 4. So that's negative 4, okay? That's negative 4. Then I push the division button, because fractions are just division problems. And then I'm going to give myself a set of parentheses, so I can put the 4 square root of 3 sort of by itself. So it's sort of, you know, it's isolated. So I'm going to say 4 times, and now the square root is right there. But see, it's in gray, so I got to push control square root. So control and this button here is going to give me a square root. and then I'm just going to make it a 3. So see that right there, and then I close my parenthesis. Oops, not right there, sorry. So I'm going to use this to move outside of the square root. See, there's already sort of one already there. It knows that that's what I'm doing. So if I push it, it's like it's sort of like really light. So the computer is assuming, or the calculator is assuming that. So I'm going to push that. Boom, I got negative 30 degrees. Now, just for giggles, let me go through this really quick. Trig, inverse of tangent, negative 1 divided by parenthesis control square root of 3, move over. Now see, here's the thing, I'm not even going to push parenthesis, I just moved over. And actually, you know what, I don't even need to move over. So when I push the push the square root of 3, I push enter, boom, what does that say? Negative 30. So either one was fine, right? So let's go back to this puppy. So that is negative 30. But what's my argument? If it's negative 30, I take 360 and subtract 30 is 330. So the last thing I was telling you was that I wanted you to put inside, when you're doing this, I want you to put it in radians. So I need to take 330 and multiply it times pi over 180, right? And so now I just got 330 over 180. So I need to find numbers that go into both of those, right? Well, I know 30 goes into both of them. So if I divide the top by 30, I get, what is that, 11? Let's find out. 330 divided by 30. Let's just make sure I'm not crazy. Yep. And then 180 divided by 30 should be, what, 6? Yep, so that's what I'm going to do. I'm going to divide both the top and the bottom by 30. So finally my theta is going to be 11 pi over 6. And so that is my argument. So finally I'm going to write my stuff here and write 8 times cosine of 11 pi over 6 plus I sine of 11 pi over 6. I wrote the pi a little smaller than I usually do just so you could see the difference between 11 and pi. And that is my answer for that one. So now I got to come over here. So let's do the same thing, right? So first we got r. R equals the square root of negative 2, because that's a squared, plus 2 squared. So that is the square root of 4 plus 4. That is the square root of 8. Now, I don't want the square root of 8. I want you to be able to take 8 and break this down to, there's a pair of 2s, so I'll pull a 2 out, and I'm left with a 2. I want you to break down the square root of 8 to that. So that's what I want for your r. Okay? Now I take the inverse of tangent of b over a, that's 2 over negative 2. So that's, those just cancel each other out, and that's the inverse of tangent of negative 1. So let's just, for giggles, let's make sure we get this right. So I'm going to go trig inverse of tangent of negative 1. And then without even hitting parentheses, I just hit the enter button. It's negative 45. Okay? Negative 45. So, 10, well, actually, I don't need to put all that. Let's just put it over here. So that's negative 45. I'm running out of room, man. Okay, and I should have made this a different color. I'm sorry. I didn't think about it. I was trying to make stuff different colors so it stood out. Equals negative 45. All right, so that's negative 45. So I know my theta is going to be 360 minus 45. So that's what, going to be 315, right? 315. And let's see, 315, does that get divided by 45? Yep, it certainly does. Okay, so now I'm going to plug and chug. Well, wait a minute. Nope, I can't plug and chug yet because I'm going to take 315 times pi over 1. Well, let me show you what. Let me not take shortcuts. All right. So we're going to go 315 times pi over 180. That's 315 over 180 pi. Now, both of those numbers can be divided by 45, right? So 315 divided by 45 is 7. So that's 7 pi. And then 180 divided by 45 is 4. So I'm running out of room here. So let's make this a little smaller and see about putting our answer right there. So that is, theta is 7 pi over 4. So now let's write our final answer. Our final answer is 2 square root of 2 times cosine of 7 pi over 4 plus I sine 7 pi over 4. And that's my answer. Ooh, that was a lot of stuff. Well, not done yet. Still got more to go. So let's finish this up. So convert the following from radians to degrees. So if you want to change radians to degrees, see the pi is on top. So I need to multiply by 180 over pi. Okay? So 3 pi over 4 times 180 over pi. The pi's cancel each other off. 4 divided by 4 is 1. 4 goes into 180. Let's see. It goes into 16, so that's 4. With 2 left over, so that's 45. So now I got 3 times 45. So 3 times 5 is 15, carry my 1. 3 times 4 is 120 plus 1, is 12 plus 1 is 130. So 135 degrees. I'm going to do the same right here. I've got 7 pi over 5 times 180 over pi. The pi's cancel off. I've got 5 divided by 5, that's 1. 180 divided by 5, that is, let's see, that's 3. What is that, 36? 3 with 3 left over, and then that's 6. Yep, so 36. So I got 7 times 36. 7 times 6 is 42, carry the 4. 7 times 3 is 21, plus 4 is 25. So that's my answer for that. Okay? So pay no attention to this stuff over her. All right, matter of fact, let's see if we can blase it bleed. Whoa, okay. We got a little mark happy. Let me try one more time. Just trying to get whoa. Now we wasting a whole bunch of time for no reason and making a whole bunch of extra marks, messing up all our cute work. So let's not do all that. That was there. Okay, yeah, let's just keep it moving. Okay, so this looks really intense. Okay, this is a 3 by 2 matrix, and this is a 2 by 3 matrix. So the two matrices, because they're multiplied, those two things cancel each other. These two things are the same. So because they're the same, I end up getting a 3 by 3 matrix. That's why I got all this mess. Okay, so now we're just going to go through. When we had 2 by 2, I kind of went through everything. I'm just going to try to hit those spots that I need to hit to give me my letters. Okay, so let's change colors because I've been doing green too long. So I've got this times that. This is the first row times the first column. I've got an A in there, so let's see what we get. The first row times the first column is going to give me this 7. The first row times the second column is going to give me that. And the first row times the third column is going to give me that. So let's see what we got. First row, first column. That's 1 times 3 plus A times the negative 2. And that gives me 7. All right, so let's look at where B is. Now I'm just going to jump and write a formula for B. B is in the third row. And so I'm going to take the third row in the first column. That gives me F. Third row, first column. That gives me F, right? So So this was first row, first column. Now I'm going to go for the third row, first column. That's going to be 5 times 3 plus b times a negative 2 equals f. Okay, this problem has two variables. That don't help me. And what I notice is that everything that's got b right now, if I do this third row and second column, I've got 5b and I've got c, so I get two variables there. Right here, if I do the third row and the third column, I've got 5 and b and d. So whatever I'm going to do there, right now I'm going to have two things, okay? So I ended up with that one. I ended up with 2 is going to be 5 times c plus b times 1 equals negative 2. And then let's go over here. So I got 3. So that's 5 times d plus b times 2 equals 1. So see, right now, these three aren't really helping me yet unless I find one of those other values. Well, I know I can find a, but I don't know about the other values yet. So let's see if we can find something specific for maybe c or d. Well, let's see, I know that the first row has an a in it. So again, that clogs me up too, because if let me just show you. So if I work the second row and the first column, watch what happens, right? So second row, first column, I get 1 times 3. No, sorry, second column. Whoa, sorry. I said, let me do the first row and the second column. So that's this one. Okay, first row, second column. That's this one. So first row, second column is 1 times c. So 1 times c plus a times 1. So that's a times 1 equals 5. Well, see again, see here, I got two values. That's not helping me. But the bright side is over here I got one value. So this problem is kind of intense because you got a lot of things you got to do. So let's see. So I still need to find something that's going to help me find E, F, and B. So let's see what else I can do. So if I work over here, I could get A and D, which, you know, matter of fact, why don't I just write these out? So let's just kind of do them all. Let's see. So first column and third row. So first column, third row is 1 times D plus A times 2 equals 11. So again, that's two variables. Both of these have two variables. Okay. So now let's look at row 2 and start hitting row 2 and column 2 and row 2, column 3. So row 2. So I've got 2, column 1. So that's 0 times 3 plus negative 2 times a negative 2 equals E. Okay, so that's beautiful. That's just numbers, and I can work with that. So let's see. Let's come up here so I can get some more space. So I got row 2, column 2. So 0 times C plus negative 2 times 1, negative 2 times 1 equals negative 2. So that doesn't really help me because it's 0 times C. So we're going to call that green as in it was sick. Okay. So next, let's look at row 2, column 3. So row 2, column 3. So I got 0 times D, again, plus negative 2 times 2 equals a negative 4. Again, that doesn't help me. We're just going to call that green because the variable isn't there. Oh, shucks, I did it again. Come on. I keep putting leaning my wrist or my fingers on my my little drawing pad, and it makes those weird lines appear. So that was 2. So now let's go to 3. I did 3 for 1, and I did 3, 3. So let's do 3, 2, and see what we get. So we've got 3, row 3, column 3. So row 3, so that's 5 times D plus B times 2 equals, I already did 3, 3, sorry. That's right there. So 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I already did this. Whoops. All right, so now let's start getting some stuff right, because that's a whole bunch of stuff. All right, and let's go to a different color too. Let's go with red because we're starting to call this. So, matter of fact, let's highlight in this pink color if we can do it without having to know extra information. So right now, those are the 2 things that I got that I don't need extra information for. Okay, so let's figure that out. So so I've got the first one, 1, 1 is 3 times 1, so that's 3, minus 2a equals 7. So I need to solve this equation. So I'm going to subtract 3 from both sides, and I'm going to have negative 2a equals 4. And then I'm going to solve that. So negative 2a equals 4 divided by negative 2 on both sides. A equals negative 2. So my a equals negative 2. So now I look again. I can use this one right here. So 2, 1. And I've got 0 plus 4 equals e. So that's easy. E equals 4. So I got E equals 4. So now I got 2 of my values. So I look to see the stuff, not the green because I can't mess with that. That's not going to help me. Right here, I have C and A. So see, because I know what A is negative 2, I can plug it in. So let's do 1, 2. That's that one. That's going to be 1 times C, so that's C. Plus A, so 1 times A is A, equals 5. And now I just replace A. A is negative 2. So I got C plus, I already said plus a negative 2, or C minus 2, equals 5. So I'm going to add 2 to both sides. C equals 7. So C, so that's B, that's C, D, E, yep. So C equals 7. So now I got C. So now I can take C, which is in this problem, and use that one to solve for B. So I'm going to take 3, 2. That is 5C plus B times 1, which is B, equals a negative 2. Well, I know what C is. C equals 7, so that's 5 times 7 plus B equals negative 2. Well, 5 times 7 is 35, right? Run out of room. 35 plus B equals negative 2. And so now I'm going to subtract 35 from both sides. B equals negative 37. So now I got my B. It's negative 37. That's a weak looking 37. Negative 37, and that's a negative 2. So now I got my B. So now, what is left? Well, I need to know D, and I need to know F. Well, right here, if I have B, see, here's B, and here's F. So I'm going to take 3, 1, and I'm going to say 5 times 3, so that's 15, minus because that's a negative 2. So minus, forget it. So 15 minus 2 times b equals f. And then I just replace b with negative 37. So that's negative 2 times negative 37, and that's 15 equals f. So I multiply those two things together. That is what, 74? So I'm running out of room here. So let's see. How about I write it right here? 5 times 3 is 15 plus, why do I keep doing that? Well, I'll just forget it. I did it. A negative 2b equals f. And so that's 15 minus 2 times negative 37 equals f. So that's 15 plus 74 equals f. So f ends up equaling 89. See, 15 plus 74, 89. So that's f. And then finally I need d. So I look around and where's my d? Well, right here, 1,3 says d. Matter of fact, well, I'll write it over just for giggles at the end. So let's do 1,3. So I got 1,3. That's 1 times d, so that's d, plus 2 times a, so plus 2a equals 11. Well, I know that a is negative 2, so that's d plus 2 times the negative 2 equals 11. So that's d minus 4 equals 11. So if I add 4 to both sides, I get d equals 15. And that's all of them. So now, if you want me to do this, so for each one of these, let's just tighten it up a little bit so you can see what we're dealing with. 1 times 3 is 3. Plus a times a negative 2, so minus 2a equals 7. That's what I got over here. And then right here, did I use 3, 2? Yeah, I used 3, 2. So that's 5 times c plus b equals negative 2. And then right here, that's 5 times d plus 2b equals 1. All right. Now, I didn't use that one, but I could plug stuff in there to see if it worked. Right here, this is c plus a equals 5. Now, we use that one. And right here, this is 1 times d plus 2 times a equals 11. We definitely use that one too. Now, we didn't use this one because, we did use this one, I'm sorry, because it was 1. We didn't use these two because all this proved was 0 times c is 0 plus a negative 2 times 1 equals negative 2. So all that would have gave me is negative 2 equals negative 2. That didn't help me, right? So then here, I've got 0 times d plus negative 2 times 2. So the 0 falls off, and I just got negative 2 times 2. That's negative 4 equals negative 4. So see, those two didn't help me. That's why I highlighted them in green. Now, I will admit, this problem is a lot. And I promise to give you some grace on this problem. All right? But that is all, and I am late for robotics, so I am going to get out of here. You guys have a nice night.